or section, I should say.
Guys,
Guys, this next section of the unit is about what we call cell processes. Sort of things that happen inside and around cells that are important for us to understand. So we're going to talk mainly about three cell processes: diffusion, photosynthesis, and respiration. Osmosis is really a type of diffusion. So what organelle is this? And this? Correct. We'll be talking about those towards the end of this section. All right, so we're going to just kind of work through the basics of solutions really, really quickly, because I think you covered that. Do you guys like study this maybe in 5th grade?
I don't know.
Concentration, solution, solid, solvent.
I don't.
All right, well, we'll go over it now. So if you imagine making some Kool-Aid, probably you all have had Kool-Aid or some similar substance before. So if we make 2 glasses of Kool-Aid here, A and B, so obviously they're different from each other, you can see from the picture. Which has a higher concentration of Kool-Aid? Yeah, of course B does. And let me ask you this question. Which has a higher concentration of water? Sean?
A.
A. So if I were to, maybe this one is 10% Kool-Aid, 90% water, and maybe this one is 2% Kool-Aid, 98% water. So they have different, what we would call these different concentrations of Kool-Aid in water. So if we imagine being able to see the Kool-Aid molecules, sample A might look like that, and sample B might look more like that. Okay. When we add the Kool-Aid powder to the water, the big chunks of the Kool-Aid powder that we can actually see get dissolved by the water and form individual molecules that they're made out of. So,
What is the fancy science for? Or what it is after the salt once it disappears?
it's a solution.
No, the
Salt is the solute.
solid.
Water is the solvent.
All right.
We're going to talk about that right here. So, when we are thinking about solutions, we can make the word we have is more dilute. If you dilute a solution, it means you add more water to it, making it a lower concentration of the solute, a higher concentration of water. When we make a solution, it has 2 parts, the solute and the solvent. The solute is the thing that sort of seems to disappear, the thing that gets dissolved. And the solvent is sort of what holds it, what contains it, what dissolves the solute. So Kool-Aid, what's the solute?
The powder.
Yeah, the powder. And the solvent?
Water.
Water. Now we're going to usually think of water as being the solvent in most all these cases, but you can have other solvents. Okay? You could have alcohol as a solvent or acetone, or lots of different substances can act as a solvent. All right, let's look at this example. So just some real simple things, we'll go through this quick. So I have some sugar water. What's the solute? Raise your hand if you can tell me. What is the solute in this case? Lily?
The sugar.
And what's the solvent, Lily?
The solvent. The water.
Water is the solvent.
You cannot say that she was wrong.
So which is which has a higher concentration of sugar? Sample A or sample B? Jack?
B.
B. Which has a higher concentration of water?
A.
Here I have salt water. In this case, what is the solute? Elizabeth?
Salt.
The salt? Solvent?
Water.
Water? Where's our higher concentration of salt molecules? Drew?
Oh, A.
And more concentration of water?
B.
B. So that sort of seems like common sense, but this one's a little different.
Oh.
Here we have dissolved some glucose in water. Okay. So in this case, what's the solute? Glucose. And the solvent? Now how about which has a higher concentration of glucose? Abby?
B,
But there's an equal number of molecules.
but there's a different number.
Correct. It's not the number of molecules that is important. It's the proportion of the solute to the solvent. So Abby's correct. Sample B has a higher concentration of these glucose molecules. Even though they're the same number, okay, because there's more water in this one, that's a lower concentration of glucose. So how does this pertain to the cell? Why are we talking about Kool-Aid? We're in the cell unit. Well, the cell membrane, as we talked about, is a thin layer, it surrounds the cell, and it controls what goes in and out. And molecules will move in and out of a cell based on their concentration. So a membrane, whether it's a cell membrane or some artificial membrane, we have some terms we use for it. We could say that it's permeable to a substance, impermeable to a substance, or we could say it's semi-permeable. So what does permeable mean? Colin?
Like, able to take?
Sort of.
I know what it is, but I'm.
Here's another,
Like what?
you could use the same root in a different context. I said, when Mr. Arcuri was in here, his odor permeated the root. What does that mean?
Invaded.
Expanded, filled up,
Invaded.
went throughout. So a membrane that is permeable means the substance can pass right through it. So if I said a membrane is permeable to salt, it means that the salt can move through the membrane. At the same time, impermeable, right? If say the castle is impermeable to invaders, okay, they cannot pass through. And so the cell membrane is what we call semi-permeable. So what do you think that means?
Sometimes it lets me, sometimes it doesn't.
Yeah, and not so much just times, but some things can pass through the cell membrane. Other things cannot pass through. Can you guess, like, what kinds of molecules could pass through the cell membrane and which could not? Richard? Glucose can go through the cell membrane. It needs some help, but it can. Generally what we think is that small molecules generally can pass through while larger molecules cannot. Okay? Things like water, oxygen, carbon dioxide, they're very, very small. They can just sort of slide through the cell membrane as if it wasn't there. The cell is permeable to those substances. However, it's impermeable to other substances, things like starch, other proteins.
Ooh, that
All right.
gross.
So if we imagine our Kool-Aid example again, and we're looking at 5 glasses of Kool-Aid, they all have different concentrations of Kool-Aid. We mean sort of the strength of the solution. So using some of the terms we've just talked about, who could describe this glass of Kool-Aid? Enough? Correct, but let's use a little bit different terminology. It has a low concentration of Kool-Aid, or you could say it has
The highest concentration.
high concentration of water, correct? about the glass on the far right? Use similar terminology to tell me about that glass of Kool-Aid. Abby?
It has a high concentration of Kool-Aid and a low concentration of water.
Correct. Taking a poll, how many people, if you could drink one of these glasses, how many people would choose this one? This one? This one? Oh.
Ew!
It's like brown.
I would choose the second to the left.
Yeah, second.
This one?
From the left.
Yeah, I would do
No,
that.
not that one.
That
You
one,
know, like that.
that one,
The one in the middle. Yeah.
Know what I thought about last night? I don't know. I was at my house and I was with my wife and my daughter, and we were all having seltzer. I was thinking seltzer has like, would you say from when you were a kid to now has like seltzer gotten way more popular?
Yeah.
I know tons of people used to say, "Oh, I hate seltzer," and now.
Yeah, I don't mind it now. I used to I physically couldn't drink it. I don't know why, but my body wouldn't let me. It's like no.
Yeah.
I don't eat
All right. So anyway, I guess I shouldn't have distracted us with this random question. All right. Next up. So let's apply this to cells. So first off, when we are referring to molecules moving back and forth, just remember from chemistry, molecules are basically the building blocks of matter. And we are talking about the movement of molecules here. And the movement of molecules in a certain way is called diffusion. This is an important definition to know. So diffusion is the movement of molecules from an area of high concentration to an area of low concentration. And so, in general, if they're able to, molecules will always move from high to low concentration, sort of on their own. It doesn't require any energy. If you imagine it like this, if I took every 7th grader in our school, I could probably force them into this classroom, and they would probably all fit. Probably not be very pleasant, probably be pretty sweaty and smelly and gross, but we could probably do it. That would obviously be a high concentration of 7th graders. Now, if I then opened up that door into that back room, what do you think would happen?
Some people would go in there.
People going to get away.
Yeah, some people would go in there. Now, would I have to tell them to go over there? They would just do it on their, would everyone go over there?
Maybe.
No. It probably over a period of a few minutes, 7th graders would sort of spread themselves out so they had a little bit more space. And then what if I opened up the doorway into the hallway?
Everybody would go.
And we'd spread out even more. Okay? So that's like diffusion. Molecules kind of act like 7th graders. They do not want to be in a crowded, tight area. They want to spread out, okay, to a lower concentration. And molecules do the same. Molecules will move from a high to low concentration. And that process is called diffusion. So for example, if Mr. Arcuri came in this room, okay, I know he told me he had black bean chili for dinner last night. And so Mr. Arcuri came in this room, pretending just to talk to us for a second, and then quickly left. We may notice a smell diffusing throughout the room. It may start in a small, little, highly concentrated odor cloud, but then those molecules of gas would bounce into each other and they would gradually spread out, when even in the far corner, Colin would be able to observe this stench throughout the room. Those molecules have diffused. If I put a drop of dye in this water,
No, do it with the lights on. Do it with the lights
Can
on.
I do it?
Also move Jack's lunch
all
pack.
right, so if I put a drop of dye in here,
Hey, no. Wait, I want to.
it's just a drop of food coloring.
Proceeds right
All right, if
there.
I put this in here,
Your hands
the
covered.
the drop starts off in, can you see like this?
No.
Oh.
That's worse.
So you start off,
That looks like my dead fish.
all of this dye is in a small area, but as this is given a little bit more time, what's going to happen? You already see it happening.
It's spreading.
Yeah, over time, the water will take on a uniform blue color because these dye molecules are spreading throughout the entire thing. We would say they're diffusing. Now, nothing has to like move, I don't have to move the molecules around, they just do it on their own. It does not require any energy. And that's what diffusion is, the movement of molecules from high to low concentration. And the reason this happens is because molecules are moving all the time. And they kind of randomly bump into each other. And as they do that, that leads them to gradually spread out over time. Okay, so these molecules have diffused from a high concentration to a lower concentration. Now, we have a special type of diffusion that we call osmosis. Osmosis is when it's water that is moving and it goes across a membrane.
Isn't like reverse osmosis something too?
Yeah, it's a way to make like purified
Pure
water.
yeah.
So if you look at this diagram, and let's really think about this for a minute. We have a U-shaped tube of plastic, and it comes apart. We actually have these, but it leaks all the time, so don't use it much. It comes apart, the tube at the bottom of the U. And you could put a membrane in between it, a piece of plastic with small, tiny microscopic holes that allows small molecules to move through, but not large molecules. So if you put a membrane in between it, you put it together, and you put two different solutions on each side. Let's say it is sugar water, and these purple dots represent sugar molecules. Where's our higher concentration of sugar?
Right.
Obviously on the right side. Lower concentration of sugar on the left. Where is there a higher concentration of water? On the left, and a lower concentration here. So which way, based on what we just talked about with diffusion, which way would you think the sugar molecules would go? To the left. However, they are too large. They can't get through the pores in this membrane. So they're stuck. Even though they're high concentration here, low concentration here, they can't get over here. What about water? What would water, how would water diffuse? Where did you tell me there was a high concentration of water? And a low concentration? Okay, so molecules want to go from high to low. Water is small enough to get through this membrane. So what do you think it does?
Goes through it.
And what do you think this looks like after? Ashley? Yeah, water from this side moves into this side, and they actually take on different heights.
How? That doesn't make any sense.
Because water can diffuse out. Now, when you look at these, how does the concentration of sugar appear?
Equal.
Should appear pretty much equal. Water would go across until it concentration equalizes.
That's amazing.
There's lots of other examples of here. This is really important when you're talking about cells in medicine. So, if a person gets, let's say the Boilermaker, every year people pass out due to dehydration. They've lost water, okay, from their blood. They pass out. Do you know what the treatment, when they bring them to the medical tent, they give them a relatively simple treatment?
Isn't it sugar water like a
So
like
Jack,
an IV
hold on.
drip?
What?
They give them an IV drip.
Yeah, they give them an IV, a bag of fluid, connected to a tube. they put into a tiny needle that goes into their vein. And what is in that bag? No.
Stuff.
So it's not water, because that would be dangerous. It would be dangerous because of osmosis. So what if they put pure water into a person's vein? Thinking about concentrations and osmosis. Pure water, what percent water is it? 100% water. How about our blood cells? What do you think our blood cells are?
They would go up the tube.
No? You mean up the IV tube? Not necessarily. So our blood cells, are they 100% water?
No.
No, but they're a lot water. Maybe they're 90% water. So you have this fluid you're putting into the vein. If it were 100% water and your blood cells are 90% water, where's the water going to go? Into the cells. Can it get through the membrane?
Yes.
Yes. And what happens to the cells? They expand and they can even burst. So they don't give pure 100% water when they're giving a person IV fluids. Can you guess what they give them? How much sugar, how much water? No.
95 to 10.
What?
90-10.
Why?
Because the life is 90% water.
They give a balanced
Perfectly
mixture
balanced.
that will still put fluid into your blood, but won't cause your blood cells to take on or to lose water. And that's why they don't just give you pure water. So if we look at these examples, these are some blood cells that have been placed in different solutions of water. So the blood cells that were placed in this first solution didn't change in size because the fluid they were in had an equal concentration of water with the blood cells. What do you think it was like here? Where was there a higher concentration of water?
The middle.
What?
Middle.
In the blood cells. And so what happened to them? No?
They shrunk.
They lost water, right? Water from inside the cell diffused out into the fluid that was a lower concentration. And they shriveled up. When cells are in very salty water, for example, they shrivel up. They lose water because of osmosis. What about this one? What happened to these cells? They got larger. Why?
Because the water had a higher concentration.
There's a high concentration of water out here, and it flowed into the cells, which had a lower concentration, and they swelled up. Drew?
What would happen if a cell does burst?
It
Yeah.
just basically it leaks its contents into the blood, and if this that kind of what's that?
What if happened on like a large
You could die.
scale?
You can die from excess water. So when I was a while back, I ran a marathon, and obviously to run a marathon, it's 26.2 miles, and people are really concerned about being hydrated and things like that. And so a lot of the education they were doing at this time was making sure people didn't overdo their hydration, because you can actually drink too much water, and it can become this sort of situation where it throws off the balance of your blood, and you can get sick. You can even die from overhydration. You know, some people think they have to drink gallons and gallons of water to prepare for like an event, but really you don't. You need to be well hydrated but not overhydrated. And so it can be dangerous to drink too much water. All right, let's stop here for today. We'll finish up our notes on that some other day. What do you got? A couple slides?
4 pages.